The biggest bottleneck in your PyTorch models isn't always the GPU, it's Python itself. Imagine achieving 30-50 faster training times, sometimes even doubling inference speeds with just one line of code. This isn't theoretical, it's a real-world revolution with PyTorch 2's torch.compile. This powerful yet often overlooked feature leverages advanced graph compilation. It takes your standard PyTorch model and transforms its dynamic Python operations into a static optimized computation graph, which is then executed by highly efficient backends like Inductor. Essentially, it's a just-in-time compiler for your neural networks. In practice, you simply wrap your model or a specific function optimized model torch, compile your model. PyTorch's Dynamo frontend traces your code, capturing all tensor operations. This graph is then passed to a backend which might perform fusion of multiple small operations into a single kernel or optimize memory access patterns. It drastically reduces the Python interpreter overhead and eliminates redundant calculations. Consider training a large transformer model on vast text datasets. Without torch.compile, Python's dynamic nature can introduce significant latency between GPU operations. With compilation, these gaps are minimized. In production, this translates to faster model iteration cycles for research teams and lower latency serving for chatbots or real-time recommendation engines. For example, Meta uses it extensively to accelerate their internal models. Historically, reaching these performance levels demanded deep CUDA knowledge, or painstakingly rewriting parts of your model in C or custom kernels. Torch.compile democratizes this optimization, making cutting-edge speed improvements accessible to any PyTorch developer without altering the model's core logic. However, a lesser-known implication is that torch.compile works best with static computation graphs. Highly dynamic models, or those relying on Python side effects that aren't pure tensor operations, might require careful handling or occasionally fall back to eager mode. Debugging can also be a unique challenge, as errors might point to compiled graph code rather than your original source. Ultimately, torch.compile isn't just a performance boost, it's a philosophical shift. It forces us to think about the entire deep learning stack, from Python code to GPU execution, and highlights how intelligent compilation can unlock hidden computational potential, pushing the boundaries of what Python can achieve in AI.